Okay, I'm back. So we are going to practice now drawing this ellipse now that we've done completing the square, and we're going to focus on using this equation over here that we put into our nice standard form. So looking at it, the center again is HK. We're going to use the opposite values. So -2, +1. We need our A, B, and C value. Our A value is the bigger number, so that's 3. Our B number is the smaller number, so that's 2. And C squared equals A squared minus B squared. This time, this number is going to be the square root of 5. So -2, +1 is our center. Our bigger number is under the Y, so that means our major vertices are going to go out in the Y direction, the bigger number, which is 3. So we're going to go up 3, and we're going to go down 3. And our minor vertices are going to go out 2. So we're going to go out 2 this way, out 2 this way. So when they talk about vertices, in my mind, they want the major vertices unless they specify. So our major vertices here are going to be, let's see, we're going up in the Y direction 3. So they're going to be -2, 4, and -2, -2. If you want to put the minor vertices in there, they're going out in the X direction. So they're going to be at 0, 1, and -4, 1. The foci, again, we could kind of draw this ellipse. This is a egg-shaped ellipse. The foci, they're going to have your values on the major axis. Square root of 5. Okay, approximate time now. Square root of 4 is 2. Square root of 9 is 3. Square root of 5 is much closer to 2. So you're just going to kind of go 2 units this way and 2 units this way. That's affecting the Y value again. There's really not a nice way to add the square root of 5 to 1. So this time you just get to write 1 plus or minus the square root of 5. Eccentricity, that's your C over A. So the square root of 5 over 3, whatever that decimal is, if you want to figure it out, you can. Square root of 5 divided by 3. That's about 0.7-ish, so it doesn't look very much like a circle. And now they threw in some major and minor axis lengths just to make sure you know which one's which. So the major axis is the bigger one. The length on each side is 3, so you would double that and get 6. The minor axis is the one that goes this way. The length on each side is 2, so you would double that and get 4. Okay, one more problem for today, and you can see it's another question where they give this to us in general form, and we need to complete the square in standard form. Perhaps you might want to hit stop right now and try this one on your own and see if you come up with the exact same answer. So go ahead and hit stop and try it. The first thing I'm going to do is I'm going to group my X values together, and I'm going to group my Y values together. And I'm going to take the 16 to this side, and now I'm not going to forget my minus sign. Factor out your GCFs. Y squared minus 2y equals a -16, and now we're ready to complete the square. So we're going to take half of this middle term, square it, and add 16 times it to the other side. We're going to take half of this middle term, square it, and add 25 times 1 to the other side. So those were actually pretty nice numbers to work with. Whole purpose of completing the square is because this factors so nicely. X minus 1 quantity squared, Y minus 1 quantity squared. And the 16s take care of each other, and you have 25 over here. So now we're going to divide everything by 25 because this side we need to equal 1. So we get X minus 1 quantity squared, and this does not reduce nicely. So you need to move the 16 to the denominator, so this is going to become 25 over 16. Nothing reduces. Think about it. If you reciprocated and multiplied, the 16 would be back on top. Over here, we have Y minus 1 quantity squared, and when you divide by 25, that becomes a 1, and this becomes a 1. Here's our nice standard form. Oops, I don't want to move that guy. Now you can't see. Okay, now we're back. So this is our nice standard form that we're going to work with. A value is the bigger number. Okay, which one's bigger? Is 1 bigger or is 25 over 16 bigger? 25 over 16 is just a little bit bigger. The square root is going to be 5 over 4. The B value is the square root of 1 or 1. And C is going to be C squared equals A squared minus B squared. So 25 over 16 minus 16 over 16, that's going to give me 9 over 16. And so my C value is 3 over 4. My center is HK, which is 1, 1. There's my center. And we are going to go out the A value in the X direction because it's under X. So we are going to go a little bit more than 1 for our major vertices. So that's affecting the X values. And so if we add 5 over 4, we're going to get 9 over 4, comma 1. And we subtract 5 over 4, we're going to get negative 1 over 4, comma 1. Those are those 2 points. Then we're going to go up 1 and down 1. So this is going to be our ellipse. It's a little bit more of a football. And we added and we subtracted 1 to the y value. So we get 1, 0, and 1, 2. Foci is always on the major vertices, and so we're going to go out 3/4. So that's not quite to 1. It's teeny tiny. It's in here, and we're adding 3/4 and subtracting 3/4. So if we add, we get 7/4, comma 1. If we subtract, we get 1/4, comma 1. Eccentricity, we are taking 3/4 divided by 5/4. So 3/4 divided by 5/4, which is 3 over 5, which is about 0.6, right in the middle of the road. And then the major vertice length, well, on the way out here, that was equal to 5/4. So if we double 5/4, that's going to give me 5/2 or 2.5. And our minor vertice length was 1, and if we double it, that gives me 2. So my minor vertice length was 2. So this is a little teeny tiny one. You aren't always going to have the nicest of numbers to work with. Okay, so tomorrow